students, welcome to mathgotserved.com. In this clip, we're going to be going over problems 16 to 20 of the next generation Accuplacer Arithmetic practice test questions. Let's take a look at question number 16. Question 16 reads, what is 0.8637 rounded to the nearest hundredth? Alright, so let's go ahead and solve the problem. Let's start by writing down the number. We have 0.8637. Now these are the steps that we're going to use to round to the nearest hundredth. First things first, you want to identify the desired place value. Okay, so we want to identify the desired place value. In this particular problem, we are aiming for the hundredths place. So where is the hundredths place here? Remember, this is the ones, okay? This is the ones place. So starting from ones, this is the 10th, and this place right here, the 6th place, is the hundredths place. Okay, so let's name it. This is the hundredths place. Now, after you identify the place value, you're going to draw a partition. Okay, so you draw a partition. What the partition helps you to do is it helps you focus your attention on where you're rounding to. So this would be our partition right here. So draw a partition behind the place value digit. In 1. Alright? Now after doing this, we're rounding to this place. This partition tells us to take a look at the digits behind the partition. Okay? If the digit to the right of the partition is less than 5, you truncate. If it is 5 or greater, you round up. Basically just add one digit to the desired place value. Okay, so step 3, look at the digit to the right of the partition. If less than 5, truncate. Okay? Truncate basically means you just cut it all off. Every digit to the right of the partition, you just truncate everything away. Alright? Or else round up. Okay? Now, what's the case here? If you take a look at 3, 3 is less than 5. So since 3 is less than 5, we're just going to simply truncate all the digits to the right of our partition. Okay? So since 3 is less than 5, we will truncate or cut off all the digits after 6. Okay, so if we want to round 0.8637 to the hundredths place, is going to be 0.86. The 37 components have been truncated. Okay, so 0.86 to the nearest hundredth. Alright, so that's how you round up. Okay, now assuming this 3 were a 7, for example, guess what? We round up. this 6 becomes a 7, and our answer will be 0.87. Okay, so anytime it's 5, 6, 7, 8, 9, you round up. If it is 4, 3, 2, 1, you truncate. Sorry. Okay, so our answer to question number 16 is option letter A. Now let's take a look at problem 17. The question is 60% of what number is equal to 30? So in this situation, we're going to translate this statement from word form into a mathematical equation, into a solvable algebraic equation. Okay? So what is it that you want to keep in mind concerning translating problems from word to symbolic format? So what you want to recall when translating from word format to symbols, algebraic, is the meaning of certain keywords. Okay? Now of represents an operation. Of represents multiplication. What represents your variable, the unknown. Let's call it, what do you want to call it? Whatever you want, call it X in this particular problem. You can call it YZ or the first letter of your name. Okay? Is equal, sometimes it's just is, but this one they say is equal. That's obvious. Sometimes it's just is. If you have is, it represents equality symbol, the equal symbol. So what we're going to do in this problem is translate the statement from verbal or word form into an algebraic format. Then we will proceed to solve the resulting algebraic equation. Okay? So we have 60% of what is 30. 60% in numerical form is 60 over 100 or 0.6. We talked about this in our previous tutorial. If you haven't seen it, you can just go to mathgotserved.com and you get a link to that, or just look in the description for access to our previous lessons. We talked about how to go from percent to decimal. So what you do is basically move the decimal point 2 places to the right. This is equivalent to dividing it by 100 and then multiplying by the appropriate conversion value to change that fractional representation into a decimal format. So 60% is 0.6. Of is what operation? Multiply. What in this case is the unknown, which we're going to call x, is the equal symbol 30. Okay? So we have 0.6 times x. 0.6x is equal to 30. Now how do we get x by itself? We have to get rid of 0.6. We have to undo the multiplication operation. So what is the inverse of multiplication? The inverse of multiplication is division. Okay, so we'll divide by that coefficient, 0.6, on both sides of the equation to preserve equality. Okay, now what do we have? We will just cancel out, divide out the 0.6's on the left side, so that yields x is equal to 30 divided by 0.6. Now if you had your calculator, you could just simply compute this, but we do not have that luxury for problems like this. So how do we compute this? If 0.6 were a number and not a decimal, then it would be easy to determine this quotient. So the question is, how can we convert the denominator into a whole number? Okay, into a non-decimal. So what we're going to do is we're going to have to identify our decimal points, and the denominator is right here and the numerator is right here. We are going to move the decimal points an equivalent number of times. Move it the number of times that will result in the denominator not being a decimal anymore. Okay, we don't care about the numerator because it is already a non-decimal. Okay, so if I move the decimal point one place to the right, okay, one place to the right, I have to move the decimal point to the numerator an equivalent number of times. What we're doing is actually multiplying the numerator and denominator by 10. Okay, that will cause the decimal point to move one place to the right. So it moves one place to the right and ends up right here and ends up right here. What is the result? This is what we have. We're going to have 300 divided by 6. This is much nicer. Our divisor is no longer a decimal. Okay, so let's go ahead and divide. The top dog goes in the doghouse. You put the 300 underneath the division symbol so it's on top. Then we are going to put the 6 here. 6 goes into 30 5 times. 5 times 6 is 30. So you just move this 0 up. Our final answer is 30. Okay? So, I'm sorry, 50. So 60% of what? 60% of 50 is 30. Answer to question number 17 is option letter D. Now let's take a look at question number 18. It reads, if 4/3 divided by 1/6 is equal to P, then the value of P is between which of the following pairs of numbers? So, first of all, let's talk about the name of the different components of a division statement or a division equation. So if we have 4/3 divided by 1/6 equals P, let's name them. Okay, so this 4/3 is your dividend. This is your dividend. 1/6 is known as your divisor. What you're dividing by. And the final result, P in this case, is your quotient. Alright? Some important terminologies to keep in mind when you're advancing to higher level mathematics. Alright, so when you're dividing fractions, what's the algorithm, what's the procedure, or what are you doing is the question. Let's write down something you want to recall concerning the process involved in dividing fractions. So something to recall is that dividing two fractions, you have your dividend fraction and your divisor fraction. Dividing two fractions is equivalent to multiplying the dividend, which is the first fraction, multiplying the dividend by the reciprocal of the divisor. Okay? I call this the drop, change, flip algorithm. You drop the first fraction, the dividend, you change your division to a times, and then you flip the divisor fraction, or you take the reciprocal and then you have a product problem to work with. Alright? So let's go ahead and apply the drop change flip algorithm in determining what the value of P is. Okay? So we have 4/3 divided by 1/6 is equal to P. So you drop this, the dividend, you change your division to a times, so that's your change, and then you flip, or you reciprocate your divisor fraction. Basically, you interchange the numerator and the denominator, okay? And that is what P is equal to. So here you can multiply and divide. 4 times 6 is 24, divided by 3 is 8. Or you can cross reduce and multiply. Let's do that. So 3 goes here 1, 3 goes here 2. And then when you multiply it out, you have, what do you have? 4 times 2 is 8. So P is equal to 8. So the question is, which of these numbers, pairs of numbers, is 8 between? 8 is between 7 and 9, right? So our answer is going to be option D, because 8 is between 7 and 9. So answer is option letter D. Alright, let's take a look at question 19. It reads, which of the following inequalities is true? So if you look at the options that we have here, you notice that what we're doing is comparing fractions. Okay, so one thing to keep in mind is write down the following tip. When comparing fractions, it's just like you're about to add them, the procedure I'm about to write. When comparing fractions, express them as equivalent fractions with identical denominators. Okay? Also known as the LCD, identical denominators. Okay, so when you're converting them into equivalent fractions, the target is to make the denominators identical. Okay, so let's start with option A. For option A, we have 3/4 is less than 5/7. Is that true or false? We don't know yet. If the denominators were identical, we'll just compare the numerators. Okay, so question, what is the LCD of 4 and 7? LCD of 4 and 7, 4 doesn't go into 7, they're co-prime, so you just multiply them together. That's a fast way to do it. 28 is the LCD. So I need to express these two fractions as equivalent fractions that have a denominator of 28. So I'll multiply the first fraction by 7, top and bottom. That will yield 21/28. And then the second one will multiply that one by 4, top and bottom. Okay, that will give us 20/28. Denominator is identical. Now compare the numerators. Is 21 smaller than 20? The answer is no, so this statement is false. Moving on to option B, we're going to execute the same procedure here. 2/3. Is 2/3 greater than 5/6? We're going to express both of them with identical denominators. What's the LCD? That's what we're looking for here. LCD of 3 and 6. If you notice, 3 goes into 6. 6 is the bigger one, so 6 is automatically the LCD. Okay? Now let's go ahead and express these two with a denominator of 6. This already has a denominator of 6, so we'll leave it alone. And then we'll focus on this one right here. Multiply this by 2 top and bottom, because 2 times 3 will give us 6. 2 times 2 is 4 over 6. Is 4 over 6 greater than 5 over 6? Look at the numerators. Is 4 greater than 5? The answer is no. So this is false. Now let's consider option letter C. Okay, so for option C, we have 5/8. Is 5/8 greater than 6 over 10? Is it? So let's find the LCD of the denominators, and then we can convert them to the desired equivalent fraction. So what is the LCD? The smallest number that 8 and 10 can go into evenly without a remainder. Okay, the LCD here is 40. If you use 80, for example, that still works. Okay, so that is not the LCD, but it still works. Now let's convert both of them to equivalent fractions with 80 as the denominator. 40 as the denominator. So times this by 5 top and bottom. That will give us 25 over 40. And then this one on the right will times by 4 top and bottom. That will give us 24 over 40. Is this a true statement? Is 25 over 40 greater than 24 over 40? Absolutely, this is true, because 25 is greater than 24. Answer to number 19 is option letter C. Now let's take a look at question 20. Question 20 reads, Carol works at a bookstore and a restaurant. In a 28-day period, Carol worked 1/4 of the days at the bookstore and did not work 1/14 of the days. On the remaining days, Carol worked at the restaurant. Question, how many days did Carol work at the restaurant during the 28-day period? Okay, so in this particular case, we're going to determine the number of days she worked at the bookstore, the number of days she did not work, and then we'll subtract them from the total number of days to get the number of days that she worked at the restaurant. Okay, so she has bookstore, she has the days she did not work, and the remaining were at the restaurant. Okay, so what we have is the following formula. This is a formula that we're going to use to determine the solution to the problem. Okay, so days at restaurant is equal to total days minus days at where? At the bookstore, minus what? Days off. Okay, the days that Carol did not work. So let's see what we know and find what we need. Total days is what? In this particular problem, we're looking at a total of 28 days. Okay, how many days did she work at the bookstore? Days at bookstore is 1/4 of the total days. So 1/4 of, remember of means multiply, 1/4 of the total number of days, which is 28. 1/4 of 28 is the same thing as 28 divided by 4, which is 7 days. Okay, so she spent 7 days at the bookstore. Now, how many days did she take off? Days off. She took a 14th of the entire period off. So 1/14 of basically means 1/14 times the total number of days, which is 28. Express this as a fraction. Multiply across, we have 28 divided by 14, and that is 2. So Carol took 2 days off. Now, how many days at the restaurant? How many days did Carol spend working at the restaurant? Days at the restaurant. We are now going to resort back to our formula, which is total number of days, which is 28, minus days at the bookstore, which is 7, minus days off, which is 2. So we have 28. We can minus 7 minus 2 is the same thing as minus 9. What is 28 minus 9? 28 minus 9. Just put a 1 here, and let me just do it vertically so you can see what I'm doing. 28 take away 9. Since 8 is smaller than 9, we borrow 1. Okay. 18 minus 9 is 9. And we have 19 days. So she spent 19 days working at the restaurant. So the answer to question number 20 is option letter B. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your preparation for the upcoming next generation Accuplacer tests, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions, comments, requests, just ask your question in the comments section below, and we'll be more than glad to support you. We have some interactive practice test questions on our website at mathgotserved.com. Do check it out. Don't forget to subscribe to our channel for updates to other math tutorials such as this. More clips can be found on mathgotserved.com as indicated earlier. Thanks again for watching, and have a wonderful day. Goodbye.